Calibration of a Zimmermann Industries volumetric mixer is a simple process. It involves determining the rate at which a particular machine will dispense a specific amount of cement, fine aggregate, coarse aggregate, water, and admixtures. In order to ensure the procedure is accurate, the actual materials you will be using to produce concrete should be used. This begins with the type of cement and supplier. There are differences in the physical properties and delivery characteristics of different brands and types of cement. If the cement is changed, a new calibration of this material will need to be done. In a like manner, the fine and coarse aggregate will vary from quarry to quarry. Another factor to be sure of is the size of the coarse aggregate. If more than one size will be used in production, each size will need to be calibrated. This can be done quickly with a Zimmermann volumetric unit due to our patented delivery system. Once the materials have been selected, the individual bins will need to be filled to a minimum of 2/3 capacities. This will ensure that the delivery mechanisms stay full during the entire calibration. The tools needed are a scale rated to at least 300 pounds and that is accurate to 0.1%. This may be electronic or mechanical. A container with a capacity of at least 2 cubic feet, about 20 gallons. A stopwatch able to measure 0.1 seconds. A calculator, Zimmermann Industries calibration worksheets, and mix design information. The mix design is the recipe for the concrete you will be producing. It defines the exact amounts of each ingredient needed to produce particular results. These will be detailed by weight and volume. Once the unit is calibrated, the desired mix design is produced and tested to ensure that the yield, or volume of concrete made, is correct. With the unit loaded, remove the fine and coarse aggregate pins at the rear of the unit. This will enable the unit to be operated while discharging only one ingredient. Remove the pins that hold the material containment flap, located at the rear of the auger, and secure it so that the container may catch all of the materials being discharged. Make sure that the water and admixture systems are also disengaged so that they will not interfere with the calibration. At this time, also ensure that the vibrators are activated. The calibration must reflect the operating conditions that will be in effect during production, and the vibrators aid in consistent flow of materials. With the auger stored and locked in the upright position, place the container beneath the discharge area. Place the cement clutch into the delivery position. At the operator station, reset the material feed counter to 0 and turn the throttle advance on. The unit must be run at operating speed. The material feed handle is engaged and the cement delivery will begin. Run the unit until a steady flow of cement is noted, ensuring that the chain is fully charged. This should take no more than 10 to 15 seconds. Remove this cement from the container and record the weight of the empty container. This will be deducted when weighing the cement so that only the amount of cement delivered is used in the calibration calculations. If the scale has a tare feature, this may be utilized. Reset the material feed counter to 0 and place the container back in position. Engage the material feed system and run the unit to a predetermined count. A counter reading of at least 30 is recommended. Use the stopwatch to record the elapsed time of this count number. The material captured is then weighed, and the weight of the cement, the exact count number, and the elapsed time are recorded on the cement calibration worksheet. This process is repeated a minimum of 5 times, with all information recorded so that an average may be computed for the amount of cement delivered and the time needed to deliver it. Either of the aggregate bins can be calibrated next. The cement clutch is disengaged so that no cement is delivered. Insert the pin that will engage the sprocket of the aggregate you are calibrating, either fine or coarse. Using the aggregate calibration worksheet, fill in the blanks at the top of the page, detailing the type and source of the material. Set the gate as noted on the worksheet. Engage the throttle advance as calibration is done under operating conditions. If calibrating the fine aggregate, be sure that the vibrators are operating during the calibration. These can be turned off during the coarse aggregate calibration. Place the container beneath the dispensing area and engage the material feed system. Run the unit until the delivery chain is completely loaded at the setting desired. If starting with the 14-gate opening, you may have to empty the container more than once before the mechanism is full. Once you have fully loaded the chain, reset the counter to 0. Engage the material feed system and run to the count number on the worksheet. Weigh the captured material, remembering to deduct the weight of the empty container. This is done a minimum of 3 times, with results recorded on the worksheet. Proceed to the next gate setting listed on the worksheet. When calibrating the coarse aggregate, it is helpful to begin at the lowest setting before moving to the higher settings. It may be difficult to lower the gate through the material. Once you have set the gate to the new level, the material that is on the chain from the gate to the dispensing area must be cleared off. This material is loaded at the previous setting, and if not cleared, will give inaccurate information. Place the container beneath the area and engage the material feed system. As noted earlier, the container may have to be emptied more than once. When the delivery chain is properly loaded, reset the counter to 0 and run to the count number noted on the worksheet. Repeat the process for 3 runs and record the weights each time. Continue to the 3rd gate setting and repeat the process. The gate settings and count numbers listed on the worksheets are to ensure that a minimum amount of material is weighed and that the sample size is adequate. Too small a sample size can result in unreliable information, as can too few samples. Once this is done for the first aggregate, the process is repeated for the second. The moisture content of the aggregate should be recorded at the time of calibration. This is done so that the correct adjustments can be made to maintain the water-to-cement ratio in the mix design. The amount of water in the aggregates is deducted from the water to be added. This will also accurately determine the weight of aggregates being dispensed. The next step in the calibration procedure is to take the information that has been recorded for the fine and coarse aggregates and plot them onto a graph. Each aggregate will have an individual graph due to the dispensing properties of the material. Using the calibration graph worksheet, plot the pounds per count at the 3 gate settings that were run. The left side of the page is marked pounds per count, and the bottom is aggregate gate settings. Once these values have been plotted, a line is drawn connecting the 3 points. Now that you have recorded all of the necessary information, the settings to produce any mix design can be ascertained. The amount of cement being dispensed is the basis for all settings. The cement is discharged at a fixed rate, and all of the other ingredients are adjusted to this value. Using the calculation worksheet, enter the mix design information into the designated lines at the top of the page. Using information from the cement calibration worksheet, fill in the pounds per count and time per count lines. The required pounds of cement is divided by the pounds per count to determine the counts per cubic yard. This value is multiplied by the time per count to determine the time per cubic yard. The required pounds of sand, the fine aggregate, is entered and divided by the counts per yard determined in the previous section, resulting in the pounds per count needed. The graph for this aggregate is now utilized. The pounds per count is located on the left side of the graph. Find the spot that the pounds per count determined is, and go directly across the sheet to the point at which this line intersects the plotted line. From this point, follow straight down, and the correct gate setting will be shown. The same procedure is followed to determine the stone, coarse aggregate setting. Water and admixtures are dispensed by flow rather than weight. This is where the time per yard information comes into use. The required gallons of water from the mix design is entered and divided by the time per yard. This will give a gallons per minute rate. The water flow meter is set to this number when operating, ensuring that the water to cement ratio remains constant. The same procedure is used to determine the admixture flow meter settings. It is important to note that admixtures are added in ounces rather than gallons per cubic yard, and often have water added to allow the liquid to flow easily. The setting of the flow meter will need to take this into account. Utilizing these sheets will enable the operator to find the correct settings for any mix design from one calibration. The final step in calibration of a Zimmermann volumetric mixer is to conduct a yield test. This is done to ensure that the material produced as per the mix design weights is a cubic yard by volume. The unit is set to produce a particular mix design. Sand and stone gates are adjusted, and the water flow meter and any admixture flow meters are set. The auger is started. The material feed system engaged. When the auger is fully charged and producing consistent material, stop both the auger and material feed together. The auger is then moved so that it is over the yield box. This box has a volume of 1/4 of a cubic yard. The count number for a cubic yard of the mix design being tested is divided by 4 to determine the 1/4 yard count. The counter is reset to 0 and the auger and material feed system engaged. The unit is run to exactly the 1/4 yard count, and the auger and material feed valves are again stopped simultaneously. The material in the yield box is then consolidated and struck off. The yield box should be level full, indicating that the mix design and calibration are correct. As we have demonstrated, calibration of a Zimmermann volumetric mixer is a simple, easy, and accurate process. Once accomplished, it enables the operator to produce a wide range of mix designs and to meet any specification called for. For more information regarding calibration, to obtain additional worksheets, or to receive a free Excel-based calibration workbook, contact us at www.zimmermannindustries.com.